Hi everyone. So my lab assistant Avery has been kind enough to be my lab assistant for today and help me to demonstrate our activities. The first thing I would like to do is to review what we learned last week. So the first thing that we learned about is how light travels. How does light travel, Avery?
Light travels in a straight line.
Awesome. So we're going to go ahead and demonstrate this. I'm going to turn the light off. Avery, grab the light. There you go. And the hairspray. Okay, let me turn the light off really quick. Okay, so Avery, shine the light on the wall. Okay, so you can see the light is going directly from the flashlight that she is holding in her hand and shining on the wall. What you can't see is the light going from the flashlight to the wall. She's going to prove to you that light travels in a straight line by spraying some hairspray into the stream. Ooh, magic! That's pretty cool. So you can see there when the hairspray is sprayed, there are the particles from the spray, and then the light is able to travel through that, and you can see the straight line of light. Okay, so the next thing, so first thing, light travels in a
straight line.
Straight line. The second thing, let me turn my lights back on. Okay. We learned about 3 different materials that light travels through. So the first material, Avery, can you go over to that window? Right now I have them covered with pillows so that it's darker down here. But if you look through that window, there are objects on the other side, but can you tell what those objects are?
Nope.
Oh, ignore my gross ceiling. So the reason you can't tell what those objects are is because this is a material that is
translucent.
Translucent materials let just some of the light travel through them. So when just some of the light travels through, we have a blurry image on the other side. Avery, go hide. Okay, Avery's hiding right now. Let's see if we can see her. Oh gosh, Avery, I can't see you. Where are you?
What about now?
Now I can see you. Why couldn't I see you before?
This wall is an opaque material.
Oh, opaque. Opaque lets how much light shine through?
None.
No light goes through. The way that I remember this one, you know how I love silly ways of remembering things. I think, oh, I cannot see you. Oh, I cannot see you. Avery was totally making fun of me for this before, but in an opaque material, no light travels through, so you cannot see what's on the other side. Oh, I cannot see you. Avery, go hide again. All right, let's see if we can find her now. Gotta turn the lights on in here though. Oh, that's not a very good hiding spot. What kind of material is that?
Transparent.
Transparent. Remember my silly way for this. A parent can see right through you when you're telling a lie, which I'm sure you never do. So transparent materials let how much light shine through?
All the light.
All of the light, so you can see a clear image on the other side. All right, you can come out now. Whoops, I lost my shoe. Okay. All right, so that's what we learned about last week. Light travels in a straight line, 3 types of materials. Opaque, oh, I cannot see you. Opaque materials do not let any light shine through. Oh, and so you can't see anything on the other side. Translucent lets some light shine through, so you get a blurry image. And transparent, your parents can see right through you, lets all of the light shine through so that you get a clear image. All right, so for today's lesson, we're looking at reflection and how light reflects off of different materials. Not yet, Avery. So we have some different materials here. We have white paper, we have something black, I have a mirror, I have crumpled up foil, and I have some smooth foil. We're going to turn off the lights and we're going to put a flashlight on each of these, and we're going to see what happens to the light. All right, so let's start with the white paper. All right, so White paper, and what you're going to learn about in one of our future labs, and this is just kind of an intro to it, but the color white reflects all light. So that's why you want to wear a white shirt during the summer, because then you're not going to get as hot. So we need evidence to prove that. So the evidence to show that is if I look up at the ceiling, look at that. I see the light on the ceiling that is being reflected off of this paper. Let's see what happens when we have the black. What do you know about black already?
Black absorbs all light.
Black absorbs all light. That's why if you walk on like a blacktop parking lot, or if you have a black shirt on in the summer, those two materials absorb all of the light's energy, so it's really hot. Now I can look up at the ceiling on this one and you can't really see anything because the light is being all absorbed into that black, it's actually Avery's paint case, so that it's going to trap most of the heat. Over here I have a mirror. So when I flash the light on the mirror, what do you think you're going to see when I look at the ceiling?
The light reflected.
Ooh, there we go. You're so smart. So you see the light that is reflected off of that smooth surface. Foil is also shiny, so that's going to cause light to reflect. But because this foil is uneven versus our smooth surface over here, smooth gave it a direct, I can actually see the circle of light. When you have light that's reflected on an uneven surface, it kind of scatters the light. So you're going to see the light on the ceiling here, but it's not going to be as bright as it was off of that smooth surface. And here's another one that's just another demonstration of a smooth surface. It's just foil that has been smoothed out. And again, you see more of the light reflected off of that smooth surface. So in summary, light is reflected off of shiny surfaces. If it is smooth, then it's going to reflect directly back in that opposite direction. If it's an uneven surface, it's going to bounce off in all different directions, so the light is not going to be as intense in that reflection. Again, here's the smooth surface. It's going to reflect equally and directly, so that will be an intense light right above it. Black absorbs all of the light energy, so you will not see any reflection from that. And white, the color white, reflects all light so that you can see that light on the ceiling. All right, I think that's all for this lab. Hope you learned a lot. Bye.